Hello, let's continue our Sudoku adventure with Rotondekunst by PjoeterBliep. So this continues our theme week for July, which is entropic-like lines, basically any lines that involve the sort of group of three logic that entropic lines do. So what do we have in store for us today? Well, we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. These yellow lines in the grid are Nabner lines. If a digit appears on the line, then the digits consecutive with it do not appear on the line, and also digits can't repeat on the line. So if this was a 2, we can't repeat the 2 on the line. That's not allowed. We also can't put a 1 or a 3 anywhere on the line. We cannot repeat. We can't put 1 or 3 because we cannot have, if a 2 is on the line, none of its consecutive digits are. If any digits on the line, none of its consecutive digits are, and it doesn't repeat. All right. I also have this singular teal line in the grid, and that is our modular line. We had that yesterday, I believe. So what you do is you take any 3 adjacent digits on the line, like these 3, these 3, these 3. They're going to have one of each of the groups 1, 4, 2, 5, and 3, 6. Those are grouped by what the remainder is after dividing by 3. So for example, if this was a 2, then in this group of 3, that is the 2, 5. We still need something from 1, 4, and 3, 6. So we need, maybe this would be a 1, and that fulfills the 1, 4 within these 3. And then this could be 6, and that fulfills the 3, 6. So that would be valid for this group of 3. But keep in mind that every single group of 3 must have that property, one of each from the group. Basically, every group has representation within every 3 that you can have adjacent. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Looks like a fish to me with a 4-eye. All right, I'm going to color this line. So first, let's start here. These 3 are, well, I'm representing the 3 groups that have to appear in these 3 cells as green, purple, and orange. I don't know which group is which. Like green could be 1, 4, it could be 2, 5, it could be 3, 6, but it is one of them. Purple is a second one, and orange is the last one. We know they're distinct groups. And so we need one of each color within every group of 3. But this is a group of 3, and it already has a purple and an orange. So our only choice is to put green here. And now this group of 3 already has an orange and a green, so our only choice is to put purple. And you'll see that that does create a cyclic quality where we always go green, purple, orange, green, purple, orange, green, purple, orange, green, purple, orange, green. The other thing we know is that there are 2 of each number in each group. So there are 2 greens, 2 purples, and 2 oranges in every row, column, and box. So for example, we have our 2 greens for this box. We have our 2 greens for this column. We can't put more greens, which may or may not be helpful. Okay, this given 4, I'm wondering what it's doing. Okay, so we know that purple cannot be the 1, 4 group because they both see a 4. These have to be different from each other, and they both see a 4. So we are going to need to... These are either 2, 5, or 3, 6. Wonder. It's interesting that we have an X-wing on them right now. Yeah, we have the purple pairs in the rows, purple pairs in the columns. Anything else? Okay, so this cell here has to be orange. It sees 2 greens and it sees 2 purples, so it must be orange. That completes the oranges for the box. So we have 2 oranges, 2 greens here, so these have to be purples. Now we have 2 purples and 2 greens, so these have to be oranges. 2 oranges, so we have a green and a purple over here. And then here we have a green and an orange. I don't know what to do with that. I'm not sure what to do with these Nabners yet. We can think about 3-cell Nabners. So... They're highly restricted. It's kind of one of the first points. As soon as I put say a 2 on an Abner, it's going to be forced to be only the even numbers, 2, 4, 6. The way we can prove that is it's got a 2 on it, so it can't have 1, 2, or 3 on it. So that leaves 4, 5, 6 only. And from 4, 5, 6, if we included a 5, it would remove both 4 and 6. So we can't include the 5, so it has to be 2, 4, 6. And then similarly, as soon as I include a 5 on it, it has to be 1, 3, 5. Because 5 removes 4 and 6, so these would be down to 1, 2, 3, but we can't actually use the 2 to remove the other 2. And so we end up with 1, 3, 5. So as soon as you place a 2 or a 5 on a Nabner, you know that it's all evens, all odds. So one thing of note is that every single group has one even and one odd in it. So the groups, no, that's not true. Is it true? Yeah. Every group has one even and one odd in it. So if a Nabner is all even or all odd, then it's got to have one of each color on it. But that's not the only choice for Nabners. As soon as you include a 1 or a 6, you get a little bit of wiggle room here. 1 does exclude 2, but then we got 3, 4, 5, 6 left. So we could, for example, include the 3 and then either a 5 or a 6. Or we could include the 4, in which case it would have to be 4, 6. So it could be 1, 4, 6, or it could be 1, 3, 5, or it could be 1, 3, 6, all of which work. So, and then 6 is similarly less restricted. So, let's see, what can we do here? We know that purple is not the 1, 4. We haven't placed a purple anywhere on Nabner. What else can we do? Is it the non-repeat property, perhaps? This is the only Nabner we've colored. So we know that this orange, whatever it is, cannot repeat on this Nabner. So orange, it could be this orange though, but it could be any of these. Huh. What am I missing about this puzzle? You'd think it would be clear. I'm going to need 2 purples and a green here for this column. Can both purples be here? I don't see why not. In fact, both purples are here. Where do the purples go in this box? These 2 purples look in. These aren't purple, so these are both purple. So now we have a purple on an Nabner, which we know is not 1 or 4. It's 2, 5, or 3, 6. Both the 2 and the 5, remember, they force all evens or all odds. 3, 6, not as lucky. So purple in, okay. Purple in this box is these 2. Right, I somehow missed that this whole time. So this is not all even or all odd, meaning it cannot have a 2 or a 5 on it. If it can't have a 2 or a 5 on it, then that means purple is not 2, 5. Right, and so as a result, we know purple's not 1, 4, we know purple's not 2, 5, purple has to be 3, 6. Ta-da! So this has 3 and 6 on it, so what's that leave for here? 6, so if we start with 1, 2, 3, 4, 5, it removes 3 and 6. Sorry. 1 through 6. It removes 3 and 6, obviously, because we can't repeat. 6 removes 5. 3 removes 1 and 2, so it can only be a 4. And so 4 is orange. This has to be green. So that has to be 1, and all the oranges are 1, 4. That has to be 1 and 4. This has to be 1 and 4 and 1. Okay. And so then we know green is the other 2. Green is the 2, 5. And so this being 2 or 5 does mean we need 1 of each on here, because we have to be all even or all odd. So we need 1 purple, which cannot go here. We have 2 purples already. So this has to be the purple, and then this has to be the orange. So we know that's 3, 6, and we know this is actually just a 1. Oh, it can't be. Sorry, this can't be hold on. Did I mess up my logic? I hope my logic was correct up till now. This can't be 1 or 4, so it cannot be orange. It also can't be purple, so it must be green. And that puts 2 greens on here, but we're not allowed to put both 2 and 5 on the same Nabner. Because if this was 2, 5, so maybe I made some kind of mistake. Let me think about this. So we can't have the 2, 5 pair, so that can't be 2, 5. And then even ignoring this 1, 4 here, the 2 removes 1, 3, and the 5 removes 4, 6. Yeah, it's just not going to happen. So this cell can't have any value. So I clearly made a mistake. What was it though? Let me go back to where I put the purples in this box. Right. Okay. So the purples had to end up here in this box. And that's 2 purples on a Nabner. Right. And so we know there's a 3, 6 pair. So we do this again, not 3, 6. 6 removes 5, 3 removes 2. Oh, it's 1 or 4. For some reason I removed 1 and I shouldn't have. Okay, that was the issue. So that's orange. And these are all 1 to 4 pairs. And I think some of them resolved, but not as many as last time. So actually we know that that's not going to end up a 1. But anyway, this is green. And we know green is 2, 5. And so now we can actually do this correctly. We need one of each color on this. And 3, 6 isn't, purple's not available. So that's orange and that's purple. And so this is 4 and 1. There we go. And that's 4 and 1. That's 4 and 1 and 4. Okay. I just one little mistake removing the 1 when I shouldn't have, but the logic was the same otherwise. That's a green 2. Oh, these are both green 2 5s. This is a 4, orange 4. So 4 removes 3. So that's 6 and 3 and 6 and 3. So we have 4 and 6. So this is 1 or 2 only. Can't be 2. So it's a 1. 1 is orange as well. Okay. And purple's 3, 6. All right. Let's see. This has to be a green 2, 5. What's going to resolve the rest of this? Probably just Sudoku here. We need an orange 1 here. We need a green 2, 5 here. I don't know what's going to resolve the 2 5s. Oh, this does. The 4 removes 5 from here. So that's 2, 5, 5, 2, 5. Oops. 2, 5, 2, 5, 5, 5. All right. And then 3, 6. This 4 resolves the 3, 6. So that's 6, 3, 3, 6, 3, 6, 6. This needs to be green, and it's 2. Let's get these 2 colors first. We need the green, and we need the purple. So that is a 3, and that is a 2, and we're done. All right, sorry about that mistake. All the logic that I figured out after that mistake was correct, other than this digit having before. Obviously, it could have and was 1. Actually, I'm kind of glad it was that kind of mistake where I had to backtrack rather than a lucky mistake and solving it in the wrong way. Cool. Well, thanks for the puzzle, PjoeterBliep. I enjoyed that. Really cool way of using Nabners to disambiguate the groupings internally. And I really liked the logic that a Nabner, if it had a 2 or a 5 on it, it had to have one of each color. That's a really cool deduction for Nabner. All right. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.